Good morning to everyone, and myself I am Dr. R. Hemalatha. I am working as assistant professor in the Department of Mathematics at the Institute of Science and Technology. Puttur. Here I am going to discuss about the mathematical logic topic. Here, logic is a language for reasoning. It is a study of principles and techniques of reason. You can observe that here logic plays a major role for the CS student because without knowing and getting the knowledge about the logic, we can't do the coding. That's why mathematical logic is kept in the syllabus of the engineering, and it is also useful for the competitive exams also because the reasoning is based on the mathematical logic. Only to get good marks in the reasoning, we have to know about the mathematical logic. Here, a statement or declaration is taken as the prepositions. Here, you can observe that the declarative sentence that is either true or false is taken as the preposition. A statement is should be true or a statement should be false, but not both. That type of statements is called the prepositions, and it is usually represented by the small letters. Connectivities and truth tables, and here you can observe that the connectivity between the declarative sentences are negation, conjunction, disjunction, conditional or biconditional, and the conditional is also called as implication, and biconditional is also known as by implication. By using the connectivities and truth tables, we can form a relation between the declarative sentences. We can go through the negation first. Negation means we are using the word not in the sentence. If you are taking the example, she is beautiful is the declarative sentence. Means if the negation of the sentence is she is not beautiful. That's why here P is the statement. You can observe that here P is the statement means the negation of the P is denoted by the symbol here negation, that is negation P, and we are using the word not in the appropriate place. It's called the negation of the given proposition. By the truth table, you can observe that P is the a statement or preposition here, and the conditions are true or false. That statement should be true or that statement should be false, and the negation of the statement is if it is true means the negation of the P is false. If the given statement, that is the declarative statement, is false means that the negation P is taken as the true. Next, going for the conjunction. For the conjunction, the relation between the declarative sentences are connected by the word and here. Here you can observe that a conjunction is only true when both P and Q are true. Here you can observe by the truth table for the declarative sentence, that is you are taking here P and another statement is taken as Q. Here you have the choices, that is true, true, false, false, and we are having the choices of the Q declarative statement true, false, true, false. Here you can observe that for the conjunction, if the statement P is true and Q is true, then the relation also becomes true, and the remaining are false. That is the rule for the conjunction. And for the disjunction, we are using the word R, and it is read as P or Q, and the symbol is here mentioned here. You can observe the by the truth table for the P declarative statements, we are taking the conditions as true, true, false, false, and for the Q statement, we are taking the true, false, true, false. The condition for the disjunction statement disjunction is here you can observe that if the statement P is false and the statement Q is false, then the statement also false. The remaining conditions are true. This is the condition for the disjunction. Next one is the conditional or implication. We have to use the words if and then. If she is getting a job means then she has to study well. That type of statements are comes under the conditional. By that truth table, you can observe that for the P statement you have the conditions true, true, false, false, and for the Q statement you have true, false, true, false. But the rule for the conditional is the first statement should be true and the second statement should be false and the result should be false and the remaining conditions are true. That is the rule for the conditional or implication, and it is denoted by if we are taking the P then Q means it is denoted by P implies Q. If the statement is Q then P, and then it is denoted by Q implies P. Then going for the by conditional or by implication, if you are taking any example means if and only if you can use in the previous you are taking the only conditional, here by conditional, that means P implies Q and Q implies P. For example, we are taking if she is studying well, then she will get a job. She is studying well, she is getting a job means here she has to study well. Like that, you are taking two sentences and we are forming the relation between and, that is P implies Q and Q implies P means then the biconditional will come, that is P double implies Q. By using the truth table, we can observe for the P statement, the rules are true, true, false, false, and for the Q statement, the condition true, false, true, false. The rule for the biconditional is if P and Q both are true, then the result will be true. If P and Q both are false, then the result will be true, and the remaining conditions are stated here as false. Here, logical equivalence statements, you can observe that that is by taking P implies Q, that is logically proved by negation P or Q. By using the truth table, we can prove that very easily also. Here also we can observe by using the truth tables by like the logical statement we can prove. Variations of the conditional. Here there is three variations, that is inverse, converse and contrapositive. By going to the converse, we are taking P implies Q means the converse of the P implies Q is taken as the Q implies P, and the contrapositive is taken as the contrapositive of P implies Q is negation P implies negation P is the contrapositive statement here. For example, you can take for the inverse statement, the P implies Q means for the converse of the state P implies Q is Q implies P. That is, if she is beautiful, then she will selected for to be an actor. If she want to be an actor means she will be beautiful, like that. The example for the converse statement. If here taking means here we have to take the negation symbol for the both Q and P, then it will comes under the contrapositive. By the truth table, you can observe that here P is the statement true, true, false, false, and Q is the statement the true, false conditions. P implies Q means the statement first statement should be true and second statement should be false. Then the result will be false. The remaining statements are true. The negation for the P is negation P. That is here true means here false, and here true means we have to take here false. Here false means you have to take the true, and here false means you have to take the true. The relation between negation P and Q. Negation P and Q means here and symbol, that is the conjunction is comes means the rules should be the both statements should be true, then the result will be true, that is here true, and also here the Q statement is true, then the result will be true. The remaining statements are all false. Valid arguments, we are going for the valid arguments. Here they are, an argument is a sequence of propositions, and the final proposition is called the conclusion of the argument, while the other propositions are called premises or hypothesis. That the given statement is taken as the premises or hypothesis of the argument. By solving the problems, we are using the premises in the first step. Here you can observe that here the sequence of prepositions are taken as P1, P2, P3 and so on, Pn, and the relation between the prepositions, that is P1 and P2 and P3 and so on, Pn implies Q is a tautology. Tautology means the totally true statements are called the tautology, and the totally false statements, here you can observe that the totally false statements is called the contradiction. Here the rules for the inference is rule P, rule T and rule CP. Here for the rule P means if we are introducing the premises or hypothesis in the derivation, then it is mentioned by the rule P. Rule T means if we are using any formula to derive the problem, then it should be comes under the rule T. And finally, if you are deriving the S from R and the set of premises R implies S is taken under the rule CP. Consistency, here the set of premises here h1, h2, h3 and so on, hn are the premises are to be consistent if their conjunction has the truth value t. Inconsistency means for every assignment of the truth values, that is h1, h2 and so on, hn is false, then it comes under the inconsistency. Proof of contradiction. In order to show that a conclusion C is false and negation C as an additional premises, here we are taking the conclusion as C is false. We are adding an additional premises, that is the negation C. Negation C means here C is false with negation C comes under true. That then the new set of premises is inconsistent. So then assumption negation is true does not hold. Then simultaneously H1 and H2 and H3 and so on, Hn is being true. The C follows the logically from the premises H1, H2 and so on, Hn. This is the proof of the contradiction, because here we are getting the result as the C is false, then we are taking the negation C as the additional premises to comes under the true. That's why it is the proof of the contradiction. Quantifiers, universal quantifiers we are taking means that is P of x is the statement that P of x is true for all values of x in the universe of discourse. Then it is mentioned by P of x or x of P of x. Here the universal quantifier is denoted by the symbol US. Normal forms. Here we are taking the prepositions P1, P2, P and so P3 and P4 and so on in the set A. It is a given statement formula for P1, P2 and so on, P and other logical variables. Here we can observe that here it contains the two powers of n rows and it is a tautology or contradiction or a contingency. This problem of finding the decision of making with two power of n rows is practically by using a computer also. It is a word sum in the place of disjunction and a product in the place of disjunction, conjunction. If you are taking the disjunction means we can add that is and symbol we are using. That way we can use a word sum. The conjunction here we are using the R symbol. That's why you are taking sum here. And for the conjunction we are taking the product. That's why you can take the symbol as the and. Elementary sum. The sum of the variables and these negations in the formula is called the elementary sum. Here you can take P and PRQ, negation PRQ and negation P as an example of the elementary sum. For the elementary product, we can take the example of P, comma, negation P and Q. Automatic theorem proving if you are taking the formula is defined as any formula is a string of formulas, and that is if alpha and beta are the string of formulas, then alpha are the string and beta and alpha are the string of formulas. Only those strings which are obtained by step 1 and step 2 are the string of formula, with the exemption of the empty string which is also a string of formula. Thank you.